Very good morning, students. Today we are going to talk about data exploration and visualization. The 4 points which we are going to see in today's class: understanding the data exploration and visualization in the context of chemical engineering, learning key techniques for data processing and visualization, exploring the tools used for data visualization, understanding how visual analytics aids decision making in chemical process. So why we need to know about this? As you know, in any chemical process, there will be a large quantity of data that we need to access and we need to collect it in order to find it out the optimized point. So when we collect the data, we need to analyze the data. Before analyze the data, we need to do the data pre-processing that I will going to cover in this part. After pre-processing, we need to look into the data through visualization mode, for which there are tools are available to look into the data by visualization technique. By techniques, AI tools or different tools are available which will help you to see the data in a visualization manner. Understanding the visual analytics, and we need to find out a decision making in chemical process by seeing the visualized data. So now we are going to see what is a data exploration and visualization. Data exploration and visualization are the first steps in understanding complex data sets. In chemical engineering, we will deal with vast amount of experimental and industrial data. Without proper exploration, valuable insights might be lost. For instance, analyzing the reaction kinetics data without first exploring it might lead to inaccurate conclusion about the reaction order or rate constant. So hope you understood the importance of data exploration and as well as the visualization because this will help you to go for a decision making. Now, what is the importance in chemical engineering? Understanding a large data sets. For example, in petroleum refining, thousands of variables affect process efficiency. Early detection of errors. Detecting sensor malfunction in a distillation column can prevent costly shutdowns. Optimizing reaction conditions. Proper visualization can help adjust temperature, pressure or catalyst concentration for better yield. Better decision making. Engineers can optimize energy consumption in a plant by visualizing energy usage data. Now we are moving to the next slide, data exploration. Data exploration involves inspecting data sets to understand their structure, patterns and key features before applying machine learning models. In chemical engineering, this is a crucial when working with data sets like sensor data from reactors, spectroscopy data from material characterization and in process control from industrial plants. So data exploration is very important. In the next part, we have different types of data exploration. The first one is data cleaning, descriptive statistics, data transformation, detecting outliers and feature selection. We will go one by one. Data cleaning. So handling missing values, duplicates and inconsistencies. Example, if a temperature readings from a reactor have missing values, imputation techniques can be used. Whereas in descriptive statistics, calculating measures like mean and standard deviation. The very good example is understanding the pH variability in wastewater treatment. The next point is data transformation, scaling and normalizing the data. Example, converting pressure readings from different units into a uniform scale. Fourth one is detecting outliers. So here we are going to talk about anomalies. In the last class I told you the anomalies is a deviation, okay, when compared to the other sets of data. Okay, so identifying anomalies using box plot. Example, detecting abnormal pressure spikes in a reactor. This is very very common in industries, chemical industries. Sometimes there will be a troubleshoot. Okay, so when the people will want to go for a troubleshooting, okay, so this is happened because of the malfunction of any process or the sensors or any type of things may happen. So when you have that type of conditions, so during the time the people ask you to do the troubleshooting. Okay, so detecting abnormal pressure spikes in a reactor is we need to address very keenly, because the pressure, as the pressure shoots up, there may be a blast. Okay, the material of the construction of the material could not able to withstand the pressure. Okay, it may be a inside pressure or maybe a vacuum. Okay, so the outside pressure is higher than the inside pressure. Okay, so there may be a buckling effect or it may be a explosion may takes place. So we should be very careful on this type of characteristics variation. And next one is feature selection, identifying the most important variables. Example, selecting key process parameters affecting polymerization reaction efficiency. So steps in data exploration. So we need to understand this data cleaning, descriptive statistics, data transformation, detecting outliers and feature selection. Next example in chemical engineering, imagine a data set recording the temperature and pressure reading from a reactor. If we don't explore the data properly, missing temperature values may lead to incorrect reaction rate calculation. Outliers in pressure reading might indicate faulty sensors. Outliers, the deviation of data from the set of data. Okay, so in pressure readings might indicate faulty sensors. And standardizing unit. Okay, for example, the pressure has been measured in psi, gauge, absolute, atmospheric pressure, bar. As we know, many units has been used actually to measure the pressure. Okay, but you can convert very well as an engineer. We can able to convert it. So this data need to become with a consistent unit. So while collecting the data, okay, or after collecting the data, we need to, before pre-processing or before processing it, we need to make the unit consistent. That is very very important, is essential for accurate predictions. Next slide is data visualization. Visualization helps in summarizing the data in a meaningful way. Instead of analyzing thousands of numbers in a table, a simple graph can reveal important trends. So by seeing the data, we could not be able to understand and predict the things. Okay, by visualization, it will be easy how the trend is, whether it is a linear relationship, how the data has been connected, or what you call is a non-linear trend. Okay, is a parabolic or a exponential, is a trigonometrical function terms like sine and cos. Okay, so we are supposed to know the trend of the data. That is very very important. For example, plotting temperature versus concentration rate in a reactor can show the optimal operating conditions. Okay, so we'll move to the next slide now. So types of data visualization. So there are univariate analysis type, bivariate analysis, and multivariate analysis is there, and multivariate analysis. Three types are there. Okay, so univariate analysis. By the word univariate is only a single variable. Bivariate means two variable. Multivariate, three or more variables. So the example for univariate analysis, a histogram showing the frequency distribution of particle size in a catalyst sample. This is a very good example for univariate analysis. Bivariate analysis, the example is scatter plot showing a pressure versus temperature in the distillation column. The third one is multivariate analysis, a heat map showing the correlation between reactor parameters like temperature, pressure, pH and concentration. Hope you understood what I am trying to say. And the next slide talks about the common visualization techniques. There are four types of charts are available, okay, which I am going to show now. One is bar chart and line graph, which has been visible over here. So Bar chart used for categorical data as the number of defective versus non-defective chemical samples. Okay, so here the data, I mean the graph is not similar, but I just for the trend, I would like to show the trend actually how the bar chart looks like, how the line graphs, sorry, how the line graphs looks like. Okay, line graphs used for the time series data such as tracking reactor, temperature over time, and the next slide is a scatter plot and histograms. So the pattern has been I have shown to you over here. Usually this scatter plot, they just draw the predicted value and the actual value. So when the people have been having values getting from the process or from the process, especially the chemical engineering process, they will check actually whether the predicted value and the actual value using the from the experiment and predicted value by using the modeling, is it close or not. Okay, so they will go for a scattered plot. Excuse me. And histograms help in analyzing the data distribution such as particle size distribution in a filtration process. What are the data visualization tools which are available? By using Python libraries, there is a matplot library, basic plotting functions are available. Okay, Seaborn statistical visualization, Plotly interactive dashboards. These are all available as a visualization tool. In our libraries, ggplot is there, Shiny for interactive web-based visualization. So other tools also are available. You can explore through internet or ChatGPT. There is a Tableau, Power BI for business intelligence and interactive analysis. So try to explore these visualization tools, any one of it, and try to understand how these tools are helpful in understanding, collecting the the information that we have collected in the form of data, how we could be able to visualize the things from which we could be able to come out with some decision regarding the process optimization and so on and so forth. So engineers can use a Seaborn to visualize the effect of catalyst loading on conversion rate in a batch reactor. So there is one of the examples, Seaborn, why to visualize the effect of catalyst loading on conversion rate in a batch reactor. So data visualization is very important. And application in chemical engineering. So what are the applications? Monitoring the chemical process, real-time sensor, data visualization helps prevent process deviation, reaction kinetics analysis, plotting concentration versus time helps determine the reaction rate, industry safety and maintenance, predicting equipment failure patterns based on vibration data from pumps, environmental impact assessment, visualizing pollutant levels over time for regulatory compliance. So a line graph tracking pH variation in wastewater treatment is a very good example, can help to identify the best neutralization strategies. So these are the applications actually of chemical engineering. So what is the necessity of going for collecting the data, visualizing the pre-processing the data, visualizing the data, and finally come out with the decision making. Hope you understood this. And what are the challenges in data exploration and visualization? So data quality issues, missing or inconsistent data, need for proper data processing. The very good example is a faulty pressure sensor giving erroneous readings in a reactor. So this may happen, the missing of inconsistent data or faulty data. This is because of a faulty sensor giving erroneous readings in a reactor. So this became an anomaly. So we may not be knowing actually why these outliers comes out, especially the data deviate from the set of data. Choosing the right visualization technique, a scattered plot is better than a pie chart for showing correlations. Example, selecting a heat map to analyze the catalyst performance across multiple variables. Interpretation errors. This is also one of the challenges. Misleading graphs due to improper scaling or axis manipulation. Example, A compressed y-axis can exaggerate minor temperature fluctuation in the reaction. So what this indicates is that while doing this process, collecting the data, eradicate the remove the some data which are not consistent, okay, and then try to find the pattern of the data, visualize the data, and then coming out the decision. During this process we should not do any type of errors. Actually it may be a human, it not be a human error especially, okay. So and also the computational error as well, okay, because the people have been, now we have been using AI tools and things like that. So if this is the error has been not debugged, actually obviously what will happen, this computational errors also will interpret the data, though the decision making will not be perfect, okay. So with this I just would like to summarize in today's class. Data exploration helps understand and clean data before analysis. Visualization makes complex data sets easier to interpret. Different techniques are available for univariate, bivariate, and multivariate analysis. Proper visualization helps chemical engineers optimize the process and ensure safety. So, with this key point, I just try to conclude today's section. That means to this part of this section. We will continue in the next class shortly. Thank you.